Welcome students.
We are excited to announce our free online classes for placement preparation, GATE and NPTEL courses.
So this question came in your placement multiple times. You have to remember how this is working. So there is a big difference between. Ladies and gentlemen, welcome. Today we will discuss about this new topic, and here are the topics. Name are WON, that is the Computer Organization Architecture, and the code is 8781. And today we will discuss the von Neumann architecture and the Harvard architecture, the bus memory transfer, the arithmetic and micro operations, logic micro operations, shift micro operations, and arithmetic, logical and shift unit. We will try to solve 1 marks question for the GATE exam and also for the competitive exam. This is very important, and we will try to complete the definitions. These are very important. The first question, actually, what is computer? A computer is an electronic device that process raw data into the useful information. It works by following a set of instructions called software, accept inputs, number first, and also its process, second, third one, it's store the data, and at last you are getting the output. Okay, that is the meaning of computer. So now what is the meaning of architecture? This is very important. Architecture means what? Okay, actually meaning is what the system will do, means instructions, registers, addressing techniques. These are the architecture. And third one is the organization. What is the meaning of organization? Organization means how. Okay, so this is what and this is how. So how the system is working? Okay, it is physically implemented just like designing and cache size and signal types. So now this is the definition of computer organization and architecture. So today the first topic we are just talking about the von Neumann. So before starting this one, there are two types of computer. The first one is the fixed program computer. First one is the fixed program computer. Their functions is very specific, and means there is no reprogrammed. Okay. Second, stored program computers means that can be programmed just like your laptop. Okay. Now what is the meaning of von Neumann architecture? Von Neumann architecture means programs, data and instructions. Already we discussed about what is the definition of data and what is the definition of instruction. So program data and instruction data are stored in same memory. Okay, that was designed by John von Neumann in 1945. This is very important. So now next topic, this topic is also same. So this already we discussed this. So this von Neumann means instruction and data are, this definition you will write in your exam. Okay, instruction and data are stored in same memory space. Later I will show you one diagram, so it is very easy to understand. Same design you have to write also in your semester and exam. And now already we talk about the CPU. CPU means central processing unit. Already we discussed what is the meaning of CPU. You go to the previous lecture and easily you will understand what is the meaning of CPU. So here I will not discuss. I will go to the next topic. So this von Neumann, okay, this von Neumann, these the components. There are three components. First one is CPU, memory and input output device. So this is the overall structure. Okay, it is made up of three components. Already we told CPU, memory and input output. I will show the diagram. Okay, how the system is working. Now at first we will discuss about the definition of bus. Okay, bus means it is a communication system that transfers data, address and controls signals between the CPU, memory and input output device. Second one, in von Neumann architecture, a single bus is shared. This is very important. A single bus is shared for both data and instructions. This is very important for your competitive exam. Okay, In the von Neumann, a single bus is shared for both data and instructions. Later I will show one diagram. It is very easy. Okay. So input output bus are input output interface and device. Device you already know. Interface already know. What is the meaning of interface? Means connected the CPU and memory. And device means you already know external hardware. That is the meaning of device. Now this is very important according to the this your semester end exam. So what is the meaning of this bottleneck actually? Okay, the instructions can only be done one at a time. What? The instructions can be done one at a time and can only be carried out sequentially. Both of these factors hold back the competence of CPU. This is commonly referred to as a von Neumann bottleneck. What is the meaning of this? Instructions can be done one at a time and can only be carried out sequentially. That is the meaning of von Neumann bottleneck. We can provide a von Neumann processor with more cache, more RAM or more faster. Okay, it will work. That is different. So this is the main meaning of this von Neumann bottleneck. Okay, what is the application? Application you already know. Number first, where both instructions and data are stored in the same memory. Okay, von Neumann architecture means where both the instructions and already know we discussed in the first lecture what is the meaning of instructions. Instruction means atomic command and data means raw, that is no meaning, unauthorized, that is the meaning of data. So what I told, both instructions and data are stored in same memory is called the von Neumann architecture. Now what is the application? Personal computer, okay, and laptops, and nowadays you are using the Intel Core i7, okay, Ryzen processors, and second one is the smartphone and tablet. Nowadays you people are using the Android 17, Android 16 and iOS Android phone. And third one is the embedded system. Okay, many people they are using the Arduino, UNO, AT, MEGA 328 and ARM Cortex M design, and also servers and cloud computing and gaming purpose. Okay, so now these are the, later I will show what is the this is the design. This designing is very important. Now you can see for the data and instructions there is only one. So only one bus, okay, for the data and instructions. Okay, so now see, later I will discuss the another architecture. The another architecture name is the Harvard architecture. If you go in the Harvard architecture, see here what is the definition. So in the Harvard architecture there are separate storage and separate bus. Okay, what I told before, there was single bus. Now here there is a separate storage and separate bus, means signal path for the instructions and data. This is the main thing. You have to write only this one in your exam. Okay, what is the features? The features, it was basically developed to overcome of the bottleneck. Okay, Venn diagram. Okay, now what is the feature? Separate memory spaces and fixed instruction length and parallel instructions and data access, more efficient memory usage, and suitable for the embedded system and limited flexibility. Okay, now if you see here, you can see that there is a before it was the separate. Now you can see for data there is another bus, and for the instructions there is another. Okay, you can see also. So there is a separate bus for instructions and data in the Harvard architecture. Other all structures are same. This is your ALU, this is your input output device or system, and that is your main memory system. Other architecture is same. If you go in the previous designing, you can see both designing are same. Main memory, ALU means control unit, and program counter and arithmetical logical unit, and that is the input output device. Now we will come here. This is the main difference. So what is the main difference? You have to remember for your this question will come in your semester end exam. Write the difference between the von Neumann architecture and Harvard architecture. Okay, so if you'll see in the ancient architecture based on the stored program computer concept, and now Harvard, you will write in the exam this one. Same physical memory address is used for instruction and data. This is important. You will write in your exam. And separate physical memory address is used for the instruction and data. This is the main to overcome of the bottleneck. Okay. And there is a common bus for the data and instruction transfer. Number first, there is a separate bus. Okay, for the data and instructions, to transfer data and instructions. Third one, which one? It is cheaper. Okay, it is cheaper, but it is costly. Okay, and CPU is not access instructions and read write at the same time. This is very important. And CPU can access instruction and read write at the same time. So this is very important. You will write in your exam. So this is 5 marks we covered. Again, this is also very important if you are not able to understand the previous. So already you know that it is used in the personal computer, and because cost is very less, and it is used in the microcontrollers and signal processing. Now this is very important. Same memory for the data instructions in the Venn diagram, and in Harvard there is a separate memory. In the von Neumann there is a single bus. In the Harvard there is a separate bus. In the von Neumann there is a simpler designing, and there is a faster design and faster access. Okay, and von Neumann there is a possible bottleneck, but there is no less bottleneck. And this is a general computer, and this is an embedded computer. Okay, so now this is we completed. Now next one is a register. You go to the previous lecture, you will understand what is the meaning of register. Now here we are discussing about the register transfer. So what is the meaning of register transfer? Register transfer is a process of moving binary data between CPU registers or between register and memory. Now it is governed by control signals and synchronized by the system clock, often described using a symbolic notations called register transfer language. So now what is the meaning of this? I will show you. Suppose you want to transfer the data. You see here, before this was the before data, and after transfer this is the address. Okay, what you have done, I transfer the address from R4 to R5 to R4. Okay, if you want to transfer the address, data can move from register to register. You have to remember. So data will move from register to register. Okay, so what logic we are using? We are using the data is registering means a transfer from R5 to R4. So now you can see before R4, this is the R4, this is the R4, this is the R4. Now you can see this is the R5, this is R5. So what we did actually, this is the R4 and this is the R5. So we transfer R5 to R4, we transfer R5 to R4. Okay, I will show you one example. Later I will show you one example. Now see here, what I told, register define the storage area that influences the data and instruction. So it can be send data and instructions from one register to another register. Okay, memory to register and memory to memory. The register transfer approach is used. Okay, if you want to transfer the data instructions from one register to another register, so we are approaching it. This register is used in the transmission of data and instructions between memory and process to implement particular task. If you know the operating system, then you can understand. So now here we use the control condition. Okay, if you want to transfer something, we use the control condition. Condition means if then. Okay, we are using if condition, then after then you are transferring. So suppose I have written if p is equal to 1, then transfer the data, means register R1 to register R2, then transfer the data from register R1 to R2. Okay, so meaning is this: if you want to send data and instructions from one register to another register, so we are using the control condition. If p is equal to 1, then transfer this data or instructions from register 1 to register 2. Later I will show in the next lectures, I will show how it is working. So now this is the diagram. If p is equal to 1, then transfer, otherwise don't transfer. So we are using also one clock. Okay, we are using also one clock. Later I will show in the next lecture, I will show how it is working. So when we will come to the register class. So now we are discussing about the bus. Next is the bus and memory transfer. So what is the meaning of bus? Already we discussed. A bus is a shared communication pathway. Okay, so a set of wires, you can say, a set of wires, okay, that transfer the data between computer component. Okay, that transfer the data between computer component. So what is the meaning of memory transfer? That's involve memory data between the CPU, okay, internal register and main memory, means RAM. That is the meaning of memory transfer. These operations dedicate how the instructions and information flow through the system. So you can say that is just like a highway. Okay, means that is just like a highway. Now if I will come to the next topic. So what is the meaning of bus? Already we discussed. So bus contains 3 categories of lines used to provide the communication between CPU and memory input output. So bus means communication between CPU and input output. So there are 3 types. Number 1 is the address lines. So the address lines carry address from CPU to memory, and input device are unidirectional. Okay, number first. Second one is the data lines. What is the meaning of data lines? The data lines carry binary data between CPU, memory and input device and are bidirectional. This is the bidirectional. It was the unidirectional. Okay, and what is the meaning of control lines? Everyone is doing same. You are transferring, actually you transfer the data or instructions from this between CPU to input output device, but that is unidirectional and this is the bidirectional. So now what is the control lines? Control line carry control and timing signals. Okay, so that is just like to control the traffic. Okay, between the CPU, memory and input output device, that is also same. Control lines, it is controlling by the timing signals. So timing signals synchronize memory and input output operation with the CPU clock. Okay, later we will discuss how the CPU clock is working. So now I will come, if they are checking also if there is any error, it's prevent the errors. Okay, so now next topic, that is very important, memory transfer. So what is the meaning of memory transfer? Memory transfer is a process of moving data between CPU registers and main memory. It's involved 2 primary operations, read and write. Okay, read means to fetch the data from the memory to CPU register. Write means storing data from the CPU register in the main memory location. So if you just talking about, there are 3 primary hardware bus actually. Number first is the hardware bus. Okay, there are 3 primary, just like I am saying how many primary colors, red, green and black are the primary colors. By the combination of these 3 primary colors, you created many different colors. Okay, 256 colors in computer science, you can say. So similarly there are 3 primary hardware buses. Number first is the address bus, carry the specific memory locations, address bit, okay, being exceed. Second one is the data bus. So what is the meaning of data bus? Transport the actual binary data between the memory unit and CPU register. Third one is the control bus. Transmit command signals such as read and write operations. Okay. So now second one, what is the second one? Memory transfer. Again, I already told there are many different type of registers you have to learn. So when the third unit will come, then you will understand what is the actual registers and how they are working. We will explain each and every topic. So this is the overview of this unit 1. So we are explaining little. Okay, later we will explain more. In computer architectures, these operations are expressed using the register transfer language. I already told. So the main memory is designed as M. Number first, the memory address register. That is the memory address register. Hold the memory address. So MAR holding the memory address, number first, and the data register, or memory buffer register, MBR. So later we will discuss how they are holding these address. Okay. So we are just defining by M. Okay. So now you can see how they are performing the read and write operations. So now if I am coming to the memory transfer, so number first is the memory read operation. A read operations transfer data stored as specific memory locations into a designated CPU register. So the concept, okay, what is the concept actually? The CPU places the target memory address into the MAR, and the memory unit then retrieve the data from that address and place it into the data register. Okay, this is the architecture, how it is working. Just like I will show you one example. Okay, suppose you have one hexadecimal address is 2000, and the memory location is equal to 2000 also. Suppose memory location is 1500, contain the value 1500. So the read command transfer 1500 into data register. How? So you can see what I am writing, M2000. Okay, so I transfer this to DR, means a data register. So what is the meaning of this? So the DR is containing the 1500. Meaning is this. This is very important, very simple actually. So what is the meaning of 2000? That is the location actually. Okay, that is the location. Now if I am coming here, writing operation, how the writing operation is working. So memory write operation also working like same. The write operations transfer data from the CPU register into a specified memory location, overwriting the previous data at that address. And what is the concept? The CPU places the target memory address into the MAR and the data to be stored in the data register. The memory unit then write this data into the address specified by MAR here also. So now you can see that how the write operation is working. So that is just opposite of the previous. Now see here, suppose you have an example. Suppose the CPU wants to store the value 45A0 into memory address 5000. The sequence places the address and the data into their respective registers and execute the write. So MAR 5000 and DR 45A0. What is the meaning of this? DR, your data register. So what I am doing, I am storing here, means result 5, your data register is 45A0. So what is the meaning of this? This address 500 is now hold this value, because you are giving the data from means you are storing the data from here to here. I already told that your compiler is always working from right to left in C programming, C++, Python also. Okay, and data structure, if you you solve the in data structure also, we explain how the linked list also working. So it is working all time, most of the time, from left to right to left. Okay, now similarly also register also working. Now we are discussing the new topic, that is the meaning of arithmetic micro operation. So arithmetic micro operations are the fundamental hardware level calculations performed on the binary data stored in CPU register. Okay, so they form the building block for all processing and execute process like addition, subtraction, increment, decrement. Okay, so now we will discuss how the ALU is performing. Okay, I will show you some very important topics. Now important topic is coming. This is very important. Number first, we are talking about the addition. So now how the addition is working actually. See here, there is a register 1 and register 2. This is holding some value and you are adding them. Then after that you are storing in R3. Example is, you can see example, R1 is equal to 001 and R2 is equal to 0010. So after operation you can see, if you are adding both value, you will get 0011. Similarly the subtraction operation also working. Okay, so how you are doing, R1 minus R3, R2 is equal to R3. Getting? So I think that we should not discuss more, because you people already completed many programs in C, C++ and Java. So no need to discuss how the registers are doing this increment operation, decrement operation. You people already done C++, C, just like C minus and D, minus D. Okay, so such type of increment, decrement operator already you have done. And how the system is working, this is very important. So system is holding the value and after then you are increasing or decreasing the value. Okay, then storing it into the same register. So now similarly also one complement and two complement also working. What is the meaning of one complement? One complement, suppose you have value 1010. So what is the meaning of its complement? Its complement is equal to 0101. Very simple. Okay, so complement means just change the signals. If there is a 0 signal, then change the signal to 0 to 1. Okay, so that is the meaning of one complement. And double complement means after then you can add 1. That is the meaning of double complement. Okay, so after then we are adding the value plus 1. Okay, that is the meaning of double complement. I think that you understand. Okay, so now we are discussing the new topic. The new topic is this is very important. Later I will show one competitive exam question. And already you people already discuss about this OR operation, JOR operation, NOT operation, and or not. Okay, if you know, JOR means this symbol, that is the meaning of A dash B plus B dash A. Okay, you already know. Okay, so and similarly also JOR operation. Okay, so these are the logic micro operations. Now shift micro operation. What is the meaning of shift micro operation? So this question later I will show. Such type of questions they are asking in your interview as well as in your placement. Okay, this is very important. Now the first one is the shift micro operation. This is very important. So shift micro operation means, suppose you have a data that is the meaning of 83. How to remember it actually? You have this value. If you are left shift, suppose you left shift means multiply by 2. You can see if you multiply by 2, so 3 2 ja 6, 8 2 ja 16. Okay, 166. Now you can see same value here. So whenever you shift something left side, so you multiply by 2. That is very simple, and it's this symbol is this one. Okay, so now you can see how the system is working. This data we shift left, 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 and this data we shift left. But one thing what we are doing, we are inserting the data from the left side, one box, and we are discarding this one. This is very important for the logical left shift. Very, very important. I will show this question came in your placement. Okay. Now next, shift micro operations. Shift micro operations. So now you can see, suppose you have a before shift, you have a data 83. How to solve this one? 83 divided by 2. So 2 4s are 8 and 2 1s are 2. 41. You can see this is also 41. Very simple. So right means you divide by 2. Okay. So that is the meaning of this symbol represent the logical right shift. Okay. Logical, remember logical right shift. So in the logical right shift, what we are doing? So we shift the data right side. We shift the data right side. Okay. But what we are doing, the last one we discard and we insert the data from the this side. Very, very simple. Now next, this is very important, arithmetic left shift. So how the arithmetic left shift is working? So arithmetic left shift, so here what is going on, the empty, the LSB is filled with 0, number first, and the MSB is discarded. Okay, this is also just like logical left shift, same. So now you can see I shift this side, I shift this side, I shift this side. So what is going on? I insert the data from here. Okay, but I reject this one. If you go in the previous, what is going on here? We rejected the output. We rejected the output in the logical left shift. So here in arithmetic, what we are doing? We rejected the input. That is the difference between the arithmetic and logical left shift. Now see here, we are showing one example. Easily you will understand. So suppose you have a data, this 1 1 1 1, and if you want to shift left, so after then before shift 1 1 1 1 and after shift this value. Okay. So what is going on actually? You can see we insert the data at this position. We insert the data at this position. So now if you go next page, you can see we insert the data at this position. Okay, I think that you understand. So here input I discard this one. Input we discard. Okay. Now we are talking about the right shift. Right shift also very similar. That is also LSB is rejected, and this is very here this box MSB and MSB you copy same as well as you shift right. Okay, and the empty most MSB is filled with the value of the previous MSB. Okay, so same thing also here, output you discard, here output you discard, here copy you same. Now I will go to the logical. See here, logical left shift, right shift, sorry, logical right shift. This is the logical arithmetic right shift and right shift. Okay, logical right shift. You can see here also I discard this one. I insert the data here and discard this one. This question came multiple times, so I am forcing multiple times you, है ना? So here also I discard, but here I copy the data here. I am not inserting, I copy here. Before I was inserting, here I did not insert, I copy same. Okay, this is a difference between logical and arithmetic. I will show why I am giving you this question multiple times, because this question came in your placement problem. Left shift, what is the meaning of left shift? See here, so this is your left shift. So if you left shift 1, so now the value is this. Okay, so this you left shift, meaning is what is the value? This is 2. Left shift means 2 into 2 4. Left means multiply by 2. If 1 shift multiply by 2, 2 shift multiply by 4, 3 shift multiply by 2 to 4 to 8, 4 shift multiply by 16. Okay, 2 then 4 then 8, then 16. If you left shift 1, multiply by 2, left shift 2, multiply by 4, left shift 3, multiply by 8, left shift 4, multiply by 16. Like this you can solve the question. Now see here another, what is this logical? This logical right shift. So this is the logical right shift. Already we explained in the logical right shift. The LSB, least significant bit, is lost and the 0 is inserted at the end position. Now see here, I am using a special symbol, this one. This is very important. What is the difference between this? This question came in your placement. This question came in your placement. So now here 1 0 1 1. Okay. So that is the logical right shift. So logical right shift, what we are doing, here we insert 0. Here we insert 0. You can see here we insert 0 and we shift, and the last one, what we have written, 0 is inserted at the end position. Okay. 0 is inserted at the end position. You can see. Okay. Now you can see also here is left shift 3. So now here 0, and after then this shift 3, 1 0 1 1. So what is the meaning of this? There is a space, there is a space, there is a space, there is a space. Okay. So what is the left? This one, left shift 3. Okay. 3 means right shift 3. 1 2 3. So this came here, and this in place of this right 0, and here no shift, no shift. So this is the final answer. You can see this is the final answer. I think that you understand. Similarly also this question also, you left shift, right shift but 1, right shift 1, right shift 3, right shift 1. Okay. So now, so this question came in your placement. Okay, this question came in your placement. Similarly, the difference between this arithmetic right shift and this is the logical right shift. This question came in your...
Our mission is to help students achieve academic and professional success.
We will guide you step by step with high-quality learning resources and practical problem solving.
For exam, what is the meaning of this? This is the arithmetic right shift, and this is the meaning logical right shift. So this question came in your placement multiple times. You have to remember how this is working. So there is a big difference between the arithmetic right shift and logical right shift. Okay, you have to remember, and how it is working. Already we explained. So language, such type of, if you will see, language, such type of handle arithmetic and logical right shifting in different ways. Suppose we are talking about the Java provides 2 right shift, such type of 2 right shift Java provide. Okay. So now, next, this is a GATE question. If you will see, this question came in the previous GATE exam. So that is the meaning of arithmetic shift, and that is the meaning of logical shift. So this question came in your GATE exam. If you, this one and this one, this question came in your GATE exam. How it is working, you already know. Okay. So how the logical is working? Okay. You have 1 1 1 1. What you will write? You will write like this. Okay. Then after then, what I am doing? In place of this, you will write 0. And after then you have to shift 1. So this one will came here. Okay. This one will came here, and this one will came here. Done. This is your final answer. That is the meaning of logical shift. And arithmetic shift, what I told, arithmetic shift, this is the arithmetic shift. In arithmetic shift, you should also know that is it left or right. You should also know. Okay. So right shift 1. So what I am doing? What I am doing? How it is working? Or if you are unable, and you can also find it like this. So minus 5 plus 2 is equal to minus 3. This is a shortcut method. Okay. Minus 5 plus 2 is equal to minus 3. Okay. Right means you are shifting to one position. Okay. Something is here. Suppose you are shifting something from here to here. So 1 2 is increasing. Okay, 1, 2 is increasing. This is a shortcut method. Now next, we are discussing about the circular shift. Circular shift is very simple actually. How the circular is working. You can see this is very easy. So this last MSB you are shifting here. Very simple. Okay. So what I told, the last one is shifting here, and these are shifting here. That is the meaning of circular shift left. Circular shift left. You are shifting left. You are shifting left. You are shifting left. You are shifting left. Done. And everything you shifted, but here in MSB you are shifting. It is at last position. So you can see number of boxes are same. Number of boxes are same. You have to remember in right circular and left circular. You can see also here what I am doing. I am shifting right. I am shifting right. I am shifting right. I am shifting right. Now what is going on? The last one LSB will come and it will shift here. So such type of many question came in your semester end exam as well as in your placement. Okay, now this is the architecture. When we will go to the 3rd unit, 4th unit, then we will discuss that how the architecture is working. Okay, so I think that you understand, and we will also discuss about the addressing mode later. Then you will understand the remaining parts. And now the last one, that is the theoretical part. The theoretical part we are discussing about the ALSU, Arithmetical Logical Shift Unit. What is the meaning of this? So that is the enhanced version of a arithmetical logical unit. That is also ALU, but it is the extension of ALU, you can say. Okay, it is a combinational digit circuit capable of performing arithmetic, logic and shift micro operations on binary data, and its core part is the CPU data path. Okay, so it's combined the arithmetical, logical and shift functionality in a single unit. Number first. Second, it's help to execute micro operations efficiently during the instruction cycle. And third one, it's a play crucial role to register transfer mechanism. So these are the very important. And what are the functional unit? The functional unit are the arithmetical unit and arithmetic unit and logic unit and shift unit. And you know that arithmetic means already you know that addition, subtraction, increment, decrement. What is the meaning of logic, and or jor, not, and what is the meaning of shift? Already we discussed about the shifting to the bits. Okay, so such type of topic already we discussed. So students, we are again telling you. Please note that we are starting 333 topics, the entire BTech syllabus, MTech syllabus, research, and that is very helpful for your semester exam as well as for the entire GATE, CSE, EIT, data science. We are covering each and every, from beginning to last. If you are enjoying the lectures, and our request also, please share the data to each and everyone, so more people they can get benefit, and clearly you can crack the exam. This is very easy. We are teaching you how to crack the exam, GATE exam, so you can get the placement. Again I am requesting to you, if you follow our instructions 100% in GATE, more than 75 marks you will get from our topic. We are covering over 100 by 100, but this is our guarantee, you will get more than 75 if you cover our 333 topics. You will get easily.
Join our learning community and start your journey towards success.
Please subscribe to the channel and press the bell icon to receive.
Thank you for watching. See you in the next class.